Okay, so we're going to try to download a suite of genes or proteins related to a specific physiological pathway. This is going to be very beneficial for identifying genes through unannotated sequences, blasting, assembling data, and kind of narrowing down what particular genes you might be interested in. First, we're going to try to see what we can do with NCBI. This is a search for CRH, maybe corticotropin-releasing hormone, and biosystems is a relatively new feature. I just want to get to there, and we'll start over fresh from there, or at least see what it comes. So it has all these different pathways that are associated with possibly the letter CRH, maybe corticotropin-releasing hormone. Let's search biosystems for cortisol, glucocorticoid biosynthesis, genes involved in that. Those should look familiar. Let's broaden it up. Let's look at everything: steroid metabolism, endogenous sterols, biological oxidation, steroid metabolism, glucocorticoid biosynthesis in there. So let's open up those. They're all open. There's 12 pathways open. Now let's display proteins. That's going to give us about 1,700 proteins. That's a pretty good set of proteins that might be of interest in physiological pathways. Let's see what happens if we display FASTA, maybe send to file. Let's save those, sure. Okay, so those downloaded. So let's import those sequences, see if we're trying to, into CLC Genomics Workbench. We could look at them in anything. This would be that. See what they look like. These are all the different sequences. So here we have a list: 1,500 genes, cytochrome P450, hydroxysteroid, 17-beta dehydroxygenase, different enzymes responsible for different pathways. So let's say that these are, a lot of these are probably going to be interested to see if there's homologs present in other organisms. Let's say oysters. How would we go about doing this? Well, one way we could do this is we could take this and I guess first rename it. And this software is nice because I believe we can simply just make a database of this, or we could blast this on a database, but let's create a local database. Okay, that's done. So then let's take some sequences, maybe some ESTs. These are all the ones in the French database. We're going to take those and blast, local blast. We are going to want to do blast X. We want to select this new database. And off it goes. Okay, so that probably wasn't the best thing to do because it's going to take too long. So what I did is I stopped that and I went the other direction. So I took those proteins and did a T-blast in against a nucleotide database of the same sequences. So basically all I did was go the other directions. No, actually I didn't do this one. I actually decided, I believe I did mollusc-EST. So these are all the unannotated ESTs from the taxa mollusca that I downloaded on a couple of years ago. There's going to be a lot of sequences. So let's let this go. So now we're only, in theory, blasting 1,500 instead of 29,000. Let's see if what kind of results we get from that. Well, it's still going. Okay, so the blast is complete now. This is individual results. For instance, we click on one of them. Look like this. We can blow it up. Look at one of the sequences. This is what it looks like. In addition to all the individual blast results, and remember this is going to be the ones in the glucocorticoid biosynthesis pathway, related pathways. There's about 1,500 proteins T-blasted in against all the molluscan ESTs in GeneBank, but we have a multi-hit, so it takes each one top blast hit. Open that up. Let's and then we would have to get a table to go back and figure out what the annotation of these queries are. But remember, there are proteins of interest based on their role in the glucocorticoid or other kind of biosynthesis pathways involved in stress, xenobiotic resistance. So we have a lot of genes in different organisms. So that's pretty handy. And the E-value is going to tell us how similar it is. Once we identify genes that are quite similar, that's going to make it easy for us to select that possible gene of interest and design primers for it to see if it might be differentially expressed in response to an environmental change.